No.
Oh. Okay, so thanks everybody for coming. This is it's exciting. Nice to round out the year with something strong. Speaking of next year, I don't have anything lined up. So if anybody is looking, and feel free to hit me up and we'll cover that here in a second. I'm gonna do a quick disclaimer and tell everybody that the microphones, you can't see them, they're these square things hanging above your heads. They are really good. And if you're whispering, you probably are whispering and they will still find you and put you on the recording. So, no matter how quiet you think you're, they're able to find you. Just as a heads up, they'll talk, you just might end up on. Quick plug for the Ford Utah Slack. This calls out the jobs channel. Also right now, because it is December, the Advent of Code channel is particularly active. We've got our own private leaderboard. You do not have to do Advent of Code and Go. You can do it in any language you want. I am biting a bullet for cross experience reasons and doing it in Java this year. I know, Paul's over here hanging his head in shame. So you can do it, and the leaderboard doesn't care how you solve the problems. It's a fun place to kind of go in there and share your solutions and kind of expand your skill set. So join us on Forge and Advent of Code. If you want to come speak here, you have a couple ways to do it. The main way is to go to this call link.
Closed.
This link is closed?
Well, I sent you, there's a new one. You should have it. It's papercall.io/Utah Go Link.
Yeah, well, I will update that and we will in the future. So
It should be in your email, Carson. Sorry.
papercall.io/Utah Go link. I don't know what that had changed. If you can't remember that, or if you want to speak, you can also just join the Forge Slack and hit me up. I'm Cardinoid. Or you can go to the meetups channel or any of the channels and just kind of say, I want to come talk. Like I said, we're bringing and clear all next year. If you don't, someone else doesn't do it, then myself or Brandon or somebody's going to end up filling in. So we'll still have the meetups, just may not have a diverse range of speakers as ours. And that's it. I don't like to do a whole ton of housekeeping, so just kind of the bare bones about who we are and what we do. And I'm gonna go ahead and hand everything from here on over to Brad, who is from Weave, and gonna talk to us about clean architecture and his thoughts. So I'm looking forward to hearing about this. Oh.
That's just if you're looking for it.
You'll share? That doesn't work, so you'll need to just join the meetup.
Yeah, you have to. I think
Yep. Sorry, I should have coordinated that a little bit.
Just fine. In a week. This is on my personal laptop. Slack should be fine to Slack.
Yeah, sorry, I coordinate this a lot more without of company and just
Just fine.
too much for granted here.
I have not presented here before, so this is all very new to me. So,
Yep, next time I'll know to not. Okay, so I said that to you. You can also go to meetup.com and go. So, and even if you come from out of work, I'll let you in and you don't have to be in your weave. That's drum looking.
Great.
There are two Carsons. Why? That's always been the dream.
One's his phone.
One big Carson. Big Carson.
It's gonna give me.
Help you, but. Fine. I mean, I should have realized we need to work, test that. I test that with all the out, like I said, I'll get, non-weed people, I go through the whole rigmarole and
Yeah.
Stay there.
should have tested it with you too.
I'm gonna get you a cup for your popcorn.
Wait.
Say something.
You just joined us, we're just having a little technical blip, so we're gonna try to get Brad sharing on the meeting.
Let's try this again. Do you want?
We're live. All right.
Up my invitation. All right. Here we go. Okay, hi. Hello, everybody. My name is Brad Hawkins. I am an engineer over at Weave. And I've been there for about 3 years now. I've been an engineer onshore level for 10 years now. And over that time, I have written some pretty horrible code that's horrible to maintain, horrible to understand, and then I would then, in some cases, pass that code off to other people. And as I was working on that, as a gentleman I learned, I got sick of trying to figure out how to, having to update 20 unit tests whenever I wanted to add a new field to a strut. And so I started kind of doing some researching on what are some good design principles on how to organize your code and get it structured in a way so this doesn't have to happen. So during that, I stumbled across a system design pattern called this patterning closely is related to hexagonal architecture. It relates to, has some overlap with linear design as well. And so as I was reading through this, there were parts of it that really resonated with me and things that I thought that I really would like to implement and kind of be a bit better about. So as I let's go through here and pull up the notes because Megan,
Is your mic muted?
it is.
Okay.
Yeah, at least my
Laptop might be.
Yeah, your laptop mic on your meet. Okay, sorry. There's, I guess, some
Yeah.
sketchy audio, and I'm sorry about that. I don't.
yeah,
I think
it's
it's
there.
good.
I've got the output of my
Yeah.
audio being
Well,
cool, so.
it'll be in the recording. If-
Okay.
If there's any
There's not much else I can do besides make sure it's not like trying to pick you up.
Okay, so I'm gonna. So what I'd like to go through now and kind of do a bit of a get some definitions about the different words that we'll be using and that I've come to appreciate and think about things with clean architecture. And so we'll go through those and then we'll go through some benefits and drawbacks, and then I'll jump into an example program that I've kind of put together about how I wrote code before I developed this and how I intend to approach it now. So very first thing that is on here in the very center of this circle, you'll see the entities. And this entities are typically types that define our business logic. And these types will vary service to service based on what your service is doing. Some of the examples that I've encountered are users, accounts, emails, or documents. And when I am working in a service, I tend to try to think about what are some of the core entities of this service? What does it do? And then I try to create those and add my business logic as methods to those types. So this will typically do things like, so in the example program we'll be looking at, we're doing a document download. And so for there, some of the particular methods you could look at are like, give me the file type for this document, or give me the URL where it can download. Things that it knows about itself. And so you'll also notice how this entities is in the center of the diagram. That indicates that this should not have any concerns with the outside world. It shouldn't care what your database technology is. It shouldn't care how it should be used. All it cares about is what can I tell you about myself, and what can I do for myself. Those are your entities. Next layer out, you'll find that there are use cases. Use cases are how you chain all of your entities and your together. How you'll implement things like creating a user or updating or maybe sending an email or something. These are things that are actually how you do what your program is supposed to do. You'll also notice that this is one layer out from the entities layer. So it is aware of different entities and the use case steps. What it is not aware of is any external services or any database technologies. Things around here this is typically where I'll define all of my interfaces for how these rules get chained together. So for example, I would have an interface here for like a user service, or it would be able to create users or update users, retrieve users. And then the implementation for that would go in another layer, where all of the database logic goes. So you'll see a use case in our example program where we go and we download a file. It gets saved as a temporary file, and then it will be deleted after the file has been uploaded to an external system. So those are going to be your use case. Next layer out, you've got REST APIs and jobs, and then databases and network devices. These are going to be how all get into your service and out of your. In this case, it says REST API, but this could be any sort of entry type. We use a lot of gRPC. This would fall in the same place. All of your ingresses are here, and that's how they get access to your system. Another thing that you can do is have cron jobs or something. We've got Kubernetes that runs cron jobs for us. I've seen them run as background processes on a Go routine. But all of these are just ways to kick off use cases from your system. One of the opinions I've got that I've had a lot of conversations with other developers about is should you have separate contracts for your inputs and outputs versus your entities? And I tend to side on the yes, you should side of this. I know it's a bit more code, but it does allow you to all your contracts and your entities. They're not lockstep the entire time. You add new fields, you can obscure things, so not everything needs to leave the service. Another thing that I like to do at this level is provide integration tests. I am a proponent of Docker Compose. I know that I've seen some conversations in the board Slack about different ways to create environments and get them spun up for testing and then spun down. My experience that I've done is I use Docker Compose. I'll typically find like a Postgres container in there, and then we use like NSQ for our event, our message bus. And so what I'll do is I can spin those up using Docker Compose, and then we get those injected into this API and job layer, and then do some acting to make sure that they are actually doing what they're supposed to. Another benefit about this that I quite like is that it allows you to test your SQL scripts to make sure your migration scripts are working as intended, and your query are doing what they're supposed to. Before doing this, it was pretty easy to push up some code to GitHub and get it merged and run it, only to find that my queries were not doing what they were supposed to. Perhaps I had messed up some Boolean logic or something. But since doing this, it's really helped me clean up my queries and verify that they are doing everything that they're supposed to do. Okay, so next layer out, we have the next side is the database and the network devices. This is where I prefer to put all of my database queries. I'll typically wrap those queries around some sort of a method name like create users or get users or update user or something like that. And then this layer will actually implement the interfaces that are defined in these cases. By doing this, it allows you to have your service be kind of agnostic about the technology that's used. It doesn't matter if you're using Postgres or MySQL or Redis or REST or gRPC. It doesn't matter. Your service doesn't care. The only thing that it knows is its business logic steps and what needs to be done. So similarly, this is the database section, and this is also the section where I tend to put my requests that go out to third-party services. This allows me to, a lot of the logic that goes in there is like setting up a request, getting your authentication token added, making sure the request payload gets formatted, and I like to have as much of that out from my business logic as possible. So I can just pass in like a user ID or something, and then I can format that entire request and then just get back a response as needed. Okay. Last circle is the configuration. This is how everything gets wired together. I like to use dependency injection to bring all of my resources out here and then get those passed in through constructors into my structs. It allows me to change what gets injected for like my unit tests. It allows me to change what gets injected for my API controller layer. So I can inject either a Docker container, connection string, or perhaps a production database or something. I have seen cases where some people have default a lot of logic out of main. I've seen main be a very simple startup script that creates an app, and your app has all of your startup logic and all of your configuring logic there. I don't have a huge preference. I think both of them have very, very valid merits and so. Okay. So we've gone through, those are all the definitions that I've got for now. Let's move on now to the benefits and the drawbacks. So some of the main benefits that I've noticed this is it allows me to have my code have a much more, much higher readability rate. I don't have to worry as much about going through and figuring out where some of my logic is in other functions and extracting that out and making it available. By having all of the related functionality grouped together, it becomes much easier to pass around and reuse. I've also found that it's much easier to test. Early on when I was first learning Go and I was writing handlers, I put the entire call in the handler. And that's kind of a nightmare to test because now you have to either spin up like an HTTP server for the tests. You then have to create all of your payload. You have to create all of your structs, and you have to test everything. Most of what you want to test for your unit tests typically tends to be business logic. So one of the main benefits I got out of this is I'm able to actually extract my code and test smaller pieces of it to make sure that it works. Smaller pieces work, and then tying everything to work on the way out continues to work as it's supposed to. Next thing I've noticed is I feel like it's much easier for me to understand what's happening in the code. I've come across code that is, you sit there and you read it and you go, I'm not sure what that does. And one of the things that I've really enjoyed about this is extracting those into smaller functions that have very clear names about what they do. So it's less about, I have to understand the function, what the implementation is, I can just understand what it's doing because it does one really simple thing. Next thing that I think helps me is with code readability. I think it's much simpler to trace through and see these smaller methods that just outline what needs to be done. And then the last thing is I think I put a lot more thought into it when I'm writing code, trying to understand what the objective is. What do I need to do? How can I organize this? I have found that I kind of take a couple of iterative approaches, one where I just get it working, the next where I start kind of breaking things out and identifying commonalities. And then I'll get to a point where I go, okay, I think this is what I want. So I tend to take more time, spend more time thinking. Last is drawbacks. There is more file structure here. What you end up doing is creating more packages. Some of them will have don't have as much in there. So it's just a lot of file structure. You do have to have more knowledge of the code. It is can get lost because you have to trim through interfaces more often, try to figure out where things. So if you might take a bit more time speed when you first come into the repo. Next one is code. You now have to create, you'll end up creating more types and more methods and things and passing them around. So there can be a bit more scaffolding to get set up. And the last one is it takes more thought. Because I spend so much time thinking about it, I'm not putting out as much code as I could. But then it comes back to, I'll have to come back and fix it later. So it's kind of a double-edged sword. Okay, so now let's go ahead and go through an example. So I've got this up in a repo under my GitHub account. It's just Bradley S. Hawkins, Go Clean Architecture. So let's go ahead and jump through that. So I'm gonna go ahead and stop presenting this window and present another one. Okay,
All the time.
is that
All Carson, all the time.
all Carson forever?
There's a lot of me on the screen right now.
Tell me, would you have it in another way?
Log into my laptop?
I can log in on another device. Multiple times.
Okay.
He just wants me to know that he is the unicorn.
Clint said that. I didn't put that up myself. That was bestowed upon me by Clint.
Beautiful. Okay, so this example program is fairly basic. I've been working on file downloads at work quite a bit recently. A lot of it has to do with taking a document and uploading it to a third-party service. Weave does a lot with integrations with third-party companies, things like dental software, orthodontic software, and oftentimes they want PDFs of things that have been filled out. So we will take PDFs and upload them into the third-party system. So in that vein, this is going to take a fairly similar approach. This particular,
You need to zoom in on that, Bob. Turn off the lights.
Oh, it's really dark when it's like dark
Very
outside.
cozy.
It is. Oh, nice.
I feel like we need some electronica.
how's that?
There we go.
Okay, now we're talking. Okay, so, let's go ahead and get started in this file. This is the endpoint handler for downloading a file. It accepts a document. It contains a download URL, a document ID of sorts, the patient that it will be associated with, and a category that you categorize it with. Insert it into the third party's system. So a lot of this is fairly standard Go code. First thing we do is we get in here, we'll encode our document, and then we'll call a method to go through and do the import. This will come in and say, can we do an insertion? Then if we can, let's go ahead and make sure that our file path exists so we don't get so all the folders exist, we don't have any issues there. Let's go ahead and come up with a name for this file. So we'll take the patient name, and in order for simplicity, I'm gonna go ahead and just throw JPEG on there because that's the sample file we'll be downloading. However, that should be able to be updated to include other types. Then we'll go ahead and we'll create a temp file at the download path where we want to store it using the pattern defined up here. We'll go ahead and create a deferred function that will clean up the file after we are done. I've commented out the line to remove it so I can show you the result after we've downloaded it and show that it succeeded. Next thing we're gonna do is we'll say, give me the document URL. This is gonna come down here and it's gonna parse the URL, make sure that everything's fine. If it were any more complicated, we could say, perhaps we're downloading the document by an ID. We could throw that there or something. From there, let's go ahead and actually download. We're gonna go ahead and we're gonna use the client. We're gonna pass in the URL and then we'll pass in a writer, which is going to be the file that we're writing to. So we'll go ahead, we'll make a request and we're gonna say we're gonna get the URL. We don't have any request body. we make the request, make sure that we close our response body, check for an invalid status code, copy the response into the writer, and then return. From there, we're gonna go ahead and seek back to the beginning of the file because we need to start reading it from the beginning. Then we'll upload it into our service. So that's the overall that's the overall goal here. Download a file from a URL, store it in a temp file, upload it to a third-party service, delete it. So first glance, this is just fine. It works. Download your file and store it. No harm, no foul. However, how do you test this? You got a couple of different problems you gotta work here. Because you have a dependency on the OS. You now have to actually provision a file, and then you're gonna have to clean it up after you're done. You have a hard dependency on the HTTP client, so now you've got to have some endpoint you can figure. And you've got some things you gotta work. You can clearly get around all that, you can clearly make it work. That's all very testable, but it takes extra work to get all that working. So this is the kind of code that I would write before. Just a lot of code in the handler, we're talking this small endpoint, 150 lines. So as it gets bigger, that will just, that's just gonna grow. So the next question is, great. Let's go ahead and see what we can do instead to kind of clean it up. What are some other things that I've tried? This is what I've tried, and this is what I settled on for how I created this. Handlers is now its own file. Its own package out of a download. Download still receives the request and decodes it. But then it converts it to the and then passes it to the use case, the document use case that knows how to import documents. So that's all he does. And then he can respond with the response he has later. Perhaps he has like an OK success or something, maybe a payload, but that's all he cares about now. He no longer cares about any business logic. From there, we come over to the document package. Document, this is the actual entity definition. This shows you all the same things that we had in our previous one. This one has a couple methods on it. In this case, it's got a single file extension method where it's hard-coded return like a PNG. This is where you would implement your code to determine what's my file extension. And then you can have some pretty simple unit tests around that to make sure that given these different criteria, do I get out what I expect? So unit test around that is much easier now than being in handlers where it was it's not even done at all, but just added right there. So it becomes a much more simple thing. The other thing that you can do is that it is an exported type. So it's very easy to keep your tests external to your package. So you get to test it at an API layer rather than an internal test package. All right, so document. We have the import function. This is where the import use case is. This is how we, this is all the business logic that we have. We download to a temp file, and then we import a document. That's all that needs to happen right now. One of the things that, that's the step for downloading. Super basic, super simple. This particular struct has two interfaces. It has the document importer. This allows it to be separated from however we want to import the document into our third-party system. This means that it can work on any of our dental softwares, any of our orthodontic softwares, whatever. It can all, as long as they implement this contract, we're set. Then we have a downloader interface. This is how we take the document and we download it from a URL and we store it to our temp file on the file system. That's all hidden behind here because all we care about is that it's stored in a temp file. Suppose you could break that up into two calls, one to create a temp file, one to pass that temp file into download, and another to and then pass that into the import. But that's just another way to cut it. So from there, that covers up our document package. That's where all of our business logic and our two layers live, in the document.go file and the import.go file. The next thing let's look at is the download file. This is where we're doing all download logic. And this is where the implementation for the download file exists. This is in our download package. And this is concerned with actually making the request and retrieving the file from a URL. So we still have the same logic about parsing out a document URL. And then we'll end up creating a new temp file here. And then we'll download to a temp file. So taking a look at download to, this is where we have all of our implementation for the HTTP request that gets sent off. So we'll create our request, make a request, close the body, check for a status code, and then copy the entire response to the temp file. And that's the download portion. It abstracts out all of the request logic. Next thing we'll talk about is the OS package, the OS file. This is in the file store package. And I called this file store because I figured this would be a great place to put all of your implementations for your different file stores. Things like GCS or S3 could all live in here because this is all around storing implementations. And the OS file is just an implementation of that. This guy just helps you set up and create temp files on the operating system in the folder structure. So this is where all the logic goes for doing that. So we still ensure that our directory exists. We format our pattern and we create a temp directory. And then we return a reference to that allows us to write and close and clean that temp file. Reason that I created a temp file struct here that wrapped it is I wanted to, and this is debatable, this is the kind of thing that I'd have a conversation with somebody about is, do you think that putting a cleanup in a close function is hiding too much? But that's what we're doing here, is this temp file is closing itself and cleaning itself up. So this is how all of the business logic for the document gets abstracted away. And so that's the refactored piece that I came up with. For completion, the manager package is just the concrete implementation for our integration. And the only thing it does is it prints out that I'm importing a document. So the last thing that I want to look at is the main function. This is where everything gets wired up and injected into each other. So this is where I come up with a file path for where I want the document to be stored. We create our integration implementation. We create our file store, our file downloader, and our document importer. And then we pass everything into our handler. And so it all gets injected in our handler. It is all wired up correctly. And all of that happens within main. So that is that's that. That's what I've got. That is my take on clean architecture, how I have attempted to write software and things that I've found beneficial. I'm excited to hear what everyone here has to say. I know I've had some conversations about clean architecture, maybe not pertaining as much to Go. I'm curious to see what you all have to say about it, what kind of benefits you've seen, practices you've tried to follow. These are opinions I've got, but I don't claim that they are absolute. And my opinion. So we're excited to hear what you guys have to say, and that's all I've got.
So do you worry that you go a bit to the over normalization, like to use a database term, like that there is a point here where nothing does anything ever.
Yes.
Everything just calls other things to call other things. And I know there's always that line, right? And here, maybe there's places where it's too much. That's my only concern about this. And anytime I also have like gut wrenching pain when I see things called an implementation, just because it gives me Java nightmares.
Oh, this is.
I'm just writing a Java.
I know.
Online.
I think it's like, yeah, anyway. So I don't know, where do you draw the line? How do you know when you've gone too far? Have you ever felt like you've gone too far with that?
Yeah, I typically tend to start with none and work my way out from there. I figure it's better to start with nothing and kind of get more and more. Find that there is, yeah, if you find you've gone too far, you get a little uncomfortable about it. Somebody gets uncomfortable about it. It's definitely worth having a conversation about.
I'm uncomfortable.
I'm
Gone too far.
Gone too far.
Odd, so don't worry about that.
Yeah, ignore it. That's pretty normal, is it? Don't be alarmed.
It's kind of an uncomfortable in general.
He loves making other people uncomfortable too.
Yeah, yeah.
As a very, very minute note, you do not need to make a directory to make temp files. OS make dir just uses the OS. If you leave an empty string. Yeah, if you put empty string in there, it'll use the default one for the operating system.
You depended on the version of Go at the time. The version of Go depended on.
I think you're using that old version of Go.
Maybe if you use it
Yeah,
really,
your
anyone
own problems.
like the last 30 years is fine.
It's still on Go 110?
No, we're good.
Okay.
I'm just saying is that I know where this came from.
Okay, yeah, no, definitely now you can just leave empty string, it'll use /temp, whatever.
As long as you're not still on Go 110.
So you had an online question as well.
Yeah, did that get answered?
Oh, I did not see that.
The hand went down, I think, but there
From
was.
Ben.
The audio in and out.
Oh, that was ages ago.
The hand went
Yeah,
down.
I had wondered if you had some kind of generator that was doing this, because I agree it's awfully verbose, and maybe I could get my head around swallowing it if I wasn't typing all of this out, but it's a lot of typing.
Yeah, I don't use a generator for a lot of this. There is a lot that probably could be constructors and everything, but I typically don't.
Have you hit bugs? My biggest worry when I get this far is if you have a lot of bugs where all your unit tests work because nothing's doing anything for real, right? And like as soon as you're writing a lot, like what this means, you don't have underscore test files here, but you're eventually gonna write a lot of mocks, right, for unit tests, like
At
that's.
some point, at some layer, yes. So like in the use case layer, yes. When it comes to like my entities, like my documents, I like to have just pure tests around there. There's no mock needed for that because it's just
Sure.
based on the fields and the methods around those fields.
But like if you're gonna test the handlers, you're gonna pass it a mock.
And
Download or whatever.
at the use, yeah, so in my import document function, yes, I would. When it comes to, I like to have integration tests, however, that use an actual database to make sure that everything works.
I see.
So I do, there are a couple of different layers of tests that I like to provide around my code to try to make sure that a mock doesn't leave something out. At some point, there does come a time though where you have to make an external call to a third party and it's like, do you mock that? Do you use the dev environment or what? So.
Yeah, no, I totally get it. I've been dealing with GCP operations lately and there is no dev environment. There's just like, you're gonna provision instances, you're gonna provision instances. So mocks are almost the only way.
Todd, do you have something?
Yeah, as a matter of common ground, do we all agree that the old original code is awful? Is anybody like saying like, nope, that was great, we should stick with that? Irregardless of how we feel about the refactor.
Yeah, I think there's definitely stuff about the original code.
It is now. And it's the first thing you write, I think it's fine.
So passive handlers are always the
It's the first thing you write.
If you try to write anything other than that first, you're probably either already know enough of the domain that you could have started with a full model.
Sure.
Like backed way into the information, but usually the first thing.
My question back to you would be this. It was fine if it worked.
No.
So that's the other thing. If,
No, what I'm trying to say, as an initial step,
Sure.
then the question is how far do you go to make it more of a readable, extendable system? Because the question I would ask the group is, how many of us have seen and or written, been guilty of, writing these interfaces that has this great abstraction layer, let's say for databases, and never change the database? Never change underneath, and yet you have all of this boilerplate on top.
Could you define never? Because if it's measured in decades, yes,
In the
but,
programmer's life at that company.
oh, definitely, yeah.
Well, at the beginning of the presentation, you said that this was driven by making a change and having to update either 20 mocks or 20 unit tests or something. And I assume that was an exaggeration for effect, but if you're making these changes to deal with the real world problem, then yeah, that's pretty defensible. If you're just making it more abstracted just because that's cleaner, then it's not so much.
I do agree that the original was basically all one function. You have to do all of your unit tests through there and try to ignore like entire code paths that weren't relevant. It's a lot of extra work to like set up the test at the very least. But yeah, to Ben's point, I think you would agree. I don't think this is a controversial statement. I think there's a lot of room between that line and where you've refactored.
Yeah.
Not necessarily saying like your way is the worst way or anything, just there's a lot of paths and people are gonna choose based on different aspects of what they value in those paths.
Absolutely. I think a lot of it comes down to personal experience. I'm sure that there's a lot of people here who come from very heavy background where there's just been, like domain-driven design everywhere, and there's just partial implementations of functions in a bunch of different places. They're very hard to trace through. I didn't come from a place where it was like that. A lot of the functions that I had to write tests against were huge, difficult, and had, just tons of different pieces in there that made it near impossible to get a full test that you could accurately say was good. And so the approach that I've taken is I want to make sure that things are smaller and more digestible rather than large and massive, difficult to reason about.
I would caveat that analogy with, if you have to eat them one at a time, a bowl of rice is too small.
To Paul's point, like, the first one was a lot easier to understand, right? If you're jumping into the code base and if it works, right? I mean, I know that this is, drawn out for effect, but specifically for downloading a file, personally, I wouldn't spend a lot of time testing that because pretty straightforward.
Right.
And so, like, personally, I would lean much closer to that first one and maybe move out a little bit from it.
So having worked with Brad and argued, I personally have argued with Brad a lot about
You're not gonna talk about the therapy thing, are you?
like, I definitely am not a fan of his approach just because but I will say it has been very effective with in getting specific code, from getting people to write tests, to have standard implementations, and especially with code reviews, people know what to look for. So I think there's been a lot of benefits that I've seen of this style of implementation. It increases the predictability. You know what you look for, especially when you're dealing with people who may not be super experienced, but you need them to write a certain level of code. You say, hey, these are my tools. These are the fundamentals. You need all of these things to have a certain amount of predictability. And that's where it's been really successful, I think. Again, I don't think Go is super object oriented in its nature, so it kind of butts heads a lot with what clean architecture does at a principle, which is object oriented. But that doesn't mean that having those kinds of philosophies behind your code are bad, because it does help you guide lots of people. Like if you have to mentor and guide a lot of people at once, it's a really easy template to just copy paste and say, here, you need something that looks like this. And I can also go work without having to hold your hand the whole time. So to your credit, Brad, I think it's very effective. And I think, yeah, maybe sometimes it adds abstraction. But if that abstraction is predictable and allows you to create a quality of code across your team, great. I think this is a good use case of that. If you don't care about binary size, if you don't care about, other kinds of things, this is fantastic. So I think it's great. Caveat, I did ask Brad to give this talk because I knew he liked it. And because I have been hearing stirrings in the Go community about trying to bring OOP back to Go in a weird way. It's like it was there and then we're like, no, that's too Java, and OOP doesn't have to be super Java. So anyway, it's kind of coming back. So I think this is anyway, that's why I asked you. I think it's a great talk, and I think there's lots of rooms to apply these principles in how we write code. And obviously you've had a lot of success with your teams in implementing them. So I say congratulations, and I enjoyed your talk. Sorry, that was really long.
Brandon. So as I see this, you do get this effect where you normalize things down, and I can kind of see like the form. The idea is you have a much larger app than this, right? And so those components are going to be probably heavily shared. How do you prevent, like on a large team, duplicate, like because you're breaking things into such small pieces, how do you prevent duplicated logic? Like, are there conventions that you use on your team to be like, you should look to see if somebody's already made something like this, or is there ways to communicate that?
That's a good question. I have found that it depends on the size of the app overall. One of the biggest apps that I've had to work on is one at Weave right now called the Sync app, which essentially functions as an everything in one app that gets installed on customer services, on customer servers. And it has a lot of already duplicated code. So a lot of it is trying to find that and condense it and bring it somewhere more universal. On services that I've started and worked on with other people on my team, it's become easier. I think that depending on, I like to try to group things by purpose, and then in some cases by like a technology. So like I'll give a Postgres package, or in this case there's a document package. So what I try to find is things that are very similar, close together, and it's much easier to find. I don't know if that. Yeah.
Well, I think we can also have another discussion about forms. Right?
I can only throw so many things tonight.
I know. But I mean, I think it's that same spectrum of art, science, context, larger groups, smaller functional, units. And I think that's where I think the caution I would say is this. Sometimes when people get into a paradigm, DDD, hexagonal, plane, that's all they can see. And so whatever context, regardless of the context, that's how they apply that.
Something about a hammer.
And I think the key, what was that?
Something about a hammer.
Yeah, and so I think the key is understand the context, why you're doing it. It's a real big thing. There's stupid things, that nobody should do. if it's sloppy code, you know, because it's 5,000 lines of code and one, you know, it's not readable. But that balance, I think, really is something that every time you do it, you ask a fresh approach, meaning, should I do it this way? Do I need to do it this way? And why am I really doing it rather than just the hammer?
And to be clear, I don't advocate that this is the best solution. It's just where I've gotten to right now. So I'm definitely wanting to continue to take input and everything from, especially other Go developers on how standards that they've got.
So, hi, my name's Matt. It's my first time here. I get the feeling a lot of you know each other, so I kind of.
Sorry.
Yeah.
Welcome to the club.
It's a little culty. And I have not done a lot of Go. I'm kind of a newbie, so I might have a bit of a rookie perspective here. I guess I'm kind of curious. I've enjoyed the discussion. This is what I came to participate in here. And I found myself agreeing with quite a bit, you know, even the stuff it's kind of contradictory. I guess I'm kind of curious, for those who, I guess for those who've been the most vocal about not loving this, what did you think of the diagram on Brad's first slide, where he had sort of the circles?
Yeah.
And I guess I'm just kind of wondering, is it philosophic? Is there a philosophical beef with just kind of separating things out into those layers, or is it more just about this sample doesn't necessarily, this isn't how we would solve this problem? I'm not actually no agenda here. I just kind of want to know how Go people think about stuff like this.
I think it might be a sample thing, just because it is supposed to be a basic sample that everyone can sort of understand. But I think it is definitely useful more on a case by case basis. It's just everyone's I don't know. I'd be careful.
But is this scary? Because I super resonate with this. I guess my background, I've done, I've gone all the way into the BIS. I've done Spring Java and back, right? And so, and
Everyone
Ruby
just
and.
say a moment of silence.
Because this speaks to me right here. Is this in the, am I amongst my people here, or is it?
Nobody, I don't think anybody's arguing with the concept of some of the stuff on display here, like injecting interfaces to kind of abstract things you're not worried about addressing the details of within the code. My original comment was, database normalization. Nobody says you should accept Google and Bigtable, but nobody says you should have one massive table with 1 billion rows for everything, right? There is a concept of normalization for a reason, but you can also over normalize your databases to the point that no row has anything but links to other rows in one data column, right? And so this is a good tool, and I use it. I use it a bunch. I did this today. Like I said, we have Google stuff where I straight up can't use the real Google APIs in most testing. So that is one of those places where I use this exact framework. But you can go so far that it actually adds complexity and it adds confusion for relatively minimal gain. And like I said, this is all the things all the way through, and that may not be actual reality, and you definitely don't start there.
So, what happened is Paul and I worked on the code.
All right, so I wrote the
So
first.
it's Paul's.
Well, I paired with Paul on that, and that was how the first one turned out, was just like that. Just like that handler. We have iterated on it from there, and we've talked about it a lot, and that's how it came to be what it is right now. This is definitely a very small sample. And it's not, I don't do everything like this the first go, but this is how it can end up, as you might bring the other.
Although I'd say, Brad, though, that I think this has influenced a lot, even on that first start. And I'm saying that in a good way. You think about why you should abstract it. The testing point, I'm doing it because of testing. That's why you're doing it versus I'm a clean, you have a tattoo of clean architecture, right?
Oh,
I know you don't. But I think that the answer to the question is also, kind of like Carson's saying, the principles here are fine. It's just how you apply them, and do you have to label it as clean? Do you have to label it as, DDD? Do you have to label it? And you can, it's fine, but use the principles where they really apply, each time.
Gotcha. Yeah, and I think maybe that's kind of like the disconnect is like, we don't have a sample with 10,000 lines of code to go through where this stuff would matter. Kind of, that's sort of what I got to, right?
Is there a certain level of complexity or a certain number of people working on a code base? Like if it's just you solving a problem, would you still reach for these tools, or is there,
No, if it's something small and basic, I'm just getting it out and working.
you know, what that?
Where that line is, oh, that's a great question.
If it was a project you knew 20 people will work on, is that enough to try to start in this direction, or 2 people, or?
Let's see here. So I would say a team of several engineers, it might make sense. If it's me on my own side project, no. But if you've got a bunch of people with hands in the pot, I think it helps kind of separate things and make it easier instead of having everybody working in one handler.
I know there's in Go, like there's people who are purists who say, right, you should have here's my proto or my REST structure, and then I have a business logic and I have a copy function over to here, and then there's a separate DB object, and they should all, be separate. I feel like it's overkill personally. I mean, I know that eventually you're gonna get some skew between database and API, but personally I say, okay, that's happened not that often for us, and it's usually not that hard of a transform. So I don't like adding all the copying, because that feels like almost more likely to introduce error than just using it.
Well, Greg, also on this one, I think it's also not just the size of the team, it's also the intent of the code. Meaning, this interface is trying to be a pattern across potentially 60 or 70 integration types. And in that case, then it makes sense to have some higher level of abstraction than you would if it's just a function that you're writing for some, it's not used except in that one context.
The handler stuff though, like that's a MVC pattern, right? Like
Yeah.
that it's a well-known pattern to make testable web frameworks is you actually should start with something that is a model that you bind the data to, and then pass it off to something that can change it, and let the rest of it just be pipes that things flow through, and it's a lot easier to. There are some parts of it that can easily apply to almost anything that you're doing.
One thing that's made it a lot more I don't know if interested is the right word, but it used to be that trying to find the implementation of an interface was terrible. And I hated trying to go through Go code, and it's like, drill into, and you're stuck, and it's like, I don't even have any idea what happened. Golang now, it will like drill in, it'll say, hey, we found this implementation of the interface. Do you want to drill to that? I think you can even default it, if there's only one implementation, to go straight to it.
Mine does that.
And that, I don't know if VS Code does that yet, but
Probably not. VS Code is really lacking on a lot of the features that Paul.
It's okay.
for me, that interface is very less opaque and terrible.
The Vim
to navigate.
the problems not explicitly implementing things, is like,
Yeah.
because it's not explicit, you can have difficulty tracking down what is actually being implemented.
Yeah.
What's interesting in this discussion is I've had that really an opportunity. I've worked in seeing how he codes,
Uh-oh.
and I've worked with Brad to see how he codes. And it's been wonderful to learn.
Who's the best?
Right. The thing is that, the reason I'm saying that is because I've learned so much from both of them in the context in which we were doing things. And there are things that I even tell Brad often, Derek would do this, right? And because I haven't, the opposite, I wouldn't say, Derek, Brad did this. But I see both being useful, and that's my comment, and I guess the essential is, don't get so caught up on one thing. do that's where the art and the science is. There really is a lot of art in this. Some people go to the science too much, that it has to be this, it's formulaic, right? And that's why I think you have to be very careful.
It's trade-offs, right? Like it's engineering, which means that like the code that he refactored to, by definition, is gaining something and losing something else. And you have to optimize for the thing that you lose not mattering to you. And that's all that ultimately matters is I made the trade-offs that are right for my team or me or my project or whatever I'm measuring against. This is why I say like, we all agree that the old code was worse, right? We don't have to agree that this intention was the right way or anything. It is an improvement. Is it an improvement in a vector that I would like? No, like I would never accept this code at Catalyst Squad ever. Because it's just very Java-esque and we eschew that.
So you know what would be
Us.
What would be interesting in that comment, it would be fun, because this is open source, right? It would be fun to actually say to the Forge community, right? This is how I would approach it and why.
I'd
Take
love
the
to see
same-
that.
take the
I
same-
really would.
Code thing, and it'd be fun to actually just have a couple.
I think you're only allowed to do that with to-do apps.
Okay. To do fun. That's true, okay. But I think that would be really beneficial for the community to actually see
I do it.
that there's not a right way. There's definitely a wrong way that I think we're thinking is true to an extent, perhaps.
I think that there's ways that everybody agrees that the cost is too high.
Yeah.
Will you go to the Golang Forge Slack channel and post? I don't know if you can. Post the
You have URL?
URL, and if you can't add us, I'll add us, and we'll see who.
To answer your question, what's your name?
January may be.
I'm gonna forget that, but I'm gonna try. I'm terrible with names. It's not you, it's me. To answer your question, that original diagram thing, I don't know what to call it, angers me. It angers me to no end because it is just so Java. Just Java to the extreme.
So
Yeah.
you have to remember that.
Take it at the scale with.
I am not representative of the Go community or any other community, so take that with a grain of salt.
Gotcha.
We're gonna close it up. I'm gonna stop the
I
recording.
could trigger just about anybody by talking about Java.
If we get a lot of uptick in the idea of a bunch of refactors, we can devote all or part of January's meetup to
Well, that could be fun.
going over people's different versions of this.
That would be great.
That'd be fun.
Very practical, hands-on,
Literally, we're gonna dissect all of your code, Brad.
Love it.
Next time, we're gonna tell you how we have to do it better.
I wanted to get into carpentry.
I don't know how to talk.
I'll talk about trade-offs some more. Like for us, we've done a very event-driven architecture. And so a lot of the complexity has been pushed into the event layer. And so, an app or something that responds to an event tends to be, often just 100 lines or a couple hundred lines of code that usually aren't that complex. And we don't, right,
Over one
to
more,
be honest, we don't
the other way.
test a lot of
too.
them because they just
That one,
work.
okay. Down.
Well, and we'd have to.
Well, we test in
Down.
production and then once it works.
Back screen, so.
3 more.
We'd have to, with this code, we'd have to add the test, right?
One more, one more.
Good one.
That's it.
Yeah.